but it shouldn't happen if you don't keep it too long. So now we're gonna do another pin. Let's try again. We're gonna clean the tip. Okay, that's good. We're gonna do, I think, pin 13. So if I set that to the side, leave it there for a little bit, and touch the solder down. And there we go. You don't need to use a lot of solder, just enough to get a solid connection on both sides. If again, we zoom in this case, it's the one on the left. So 13 there. If you look at it from the side, you guys can see that it has that volcano shape. That one's not as pretty as the first one. You guys can see that the first one is shinier, but it would still have a solid connection. As long as you're covering that whole circle, that gold looking circle with solder and keeping that volcano shape, you should be good. So I'm gonna do a couple others on the other side, and I'll let you guys do the rest. Actually, I'm gonna do ground now. Well, first I'm gonna do some on the other side. Okay, so I flipped the board around. Make sure the tip is clean. Also, don't do this, but just to show how hot the iron is. Okay, so here we go on the other side. We'll do a 3 just because it's in the center. If you're finding this tip to be too thick, there's also this pack with, I think, a thinner one, the one on the very right, and there's instructions in the booklet on how to replace them. Make sure the iron has cooled off before you try to replace any of them. So here we go. Put it to the side, touch the solder to it. Then wait a little bit. And there we go. Look at that. So A4 is the one we're looking at. Turn this around. And you guys can see it has that nice volcano shape. And the whole gold colored plating is covered. Again, not as pretty as the 11. It's the one on the right. Give the camera 1 second to focus. But any of these would work. Okay, so now we're gonna hit one of the harder ones. Also, make sure the pins are flat or as perpendicular to the board as you can get them. It'll be easier to stick it in the breadboard if they're perpendicular. My camera kind of shows them not very straight, but they're mostly so. As long as it can stick in the breadboard, you'll be fine. So there's a ground. Okay, we're gonna do the ground. Ground pin is gonna be harder because for the solder to flow, the metal pad that's gold colored needs to be hot enough. And the ground has a lot more surface area. It's connected to a big metal plate in the center of the board or someplace along the board. So it's going to take a lot more heat to get it to the temperature for solder to flow, as you guys will see shortly. So this one is harder it's the hardest pin to solder in the board. And if there's two grounds, one of the two hardest. Okay. Set it for a bit. We'll wait a couple seconds and we'll try. Just give it a little bit more time than you did the other ones. Okay. And when you're soldering, you want to stay steady. You don't want to tap, 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 because it won't let the whole metal around it get up to temperature. Let's see how I did. Go to ground. Okay, the whole gold circle is covered. It looks okay. Oh, I don't know if you guys can see, but that pin is no longer parallel with the other ones. If you look at it from the bottom, I'll wait for the camera to focus again. So as you guys can see, this pin is sort of to the side. That's because I think I held the soldering iron long enough to where the plastic at the bottom holding these header pins together melted enough to let the metal pin wiggle. It'll still work. Just be mindful that that may happen if you leave the soldering iron too long. As for the connection, it should work fine. It's not the prettiest soldering job, but it'll do the trick. That triangular shape showed us it flowed down. So don't worry about making your soldering super pretty. Try not to go back to something you've done just because of that chance of delaminating or moving those pins. You might want to go back if you think the solder didn't flow through, but if it just doesn't look the prettiest, don't worry about it too much. So now we need to do that for each and every one of the pins. As you get a little bit more comfortable while soldering these, you'll notice that you can go by pretty fast, just one after the other. I'll do a couple on video, then I'll do the rest off camera. So here we go. Oh. You might want to change to a thinner tip so you can fit between the two pins. I think the temperature is really high right now. That's why each of these is going so fast. I might have shifted it with my finger. You can always turn it down if you're worried that you're going to burn through something, and if it's not getting hot enough, you can just turn it up. It's safer to go from lower to higher than from high to low. Also, something that I was taught at Mbari about soldering is make sure you have the most points of contact as possible with your hands so that you're not floating in midair. It's really hard to hold something steady if you have nothing to rest your hand on. You're going to see that your hand will be little bit shaky and a little bit hard to hold the tip of the soldering iron in a specific location. So in this case, I'm resting my hand on the table as well as the hand holding the solder, so I can hold it and have this relaxed position where I can stay for a while and not move the tip too much. And let's take a look to see how those went. So again, some of those are not the prettiest. I think 10 in particular, I used a little bit too much solder. But these should all be fine. I was able to find some AA batteries, which is what the multimeter takes. The battery casing is on the back with a screwdriver that comes in the kit. You can remove that and put the batteries in. Then the kit also comes with wires for the multimeter, red on this symbol, black on COM. And so we're going to use this to test if, even though I messed up, if I would be able to have a connection with those pins. And this will also allow you to test if your connections are solid. So in this case, we're going to go to conductivity, which is this symbol over here. And what that means is if current is able to flow from point A to point B, we're going to get a beep. So grab something that's metal, like these pliers, and touch these leads to 2 points on it. We get that beeping sound, which means that there's a connection or that electricity can flow from point A to point B. So we're going to try that with our board now. So you can test ground using this. So this would be ground and the pin ground, and you guys can hear the beeping. I think there should be another ground pin. Maybe there isn't. I think there isn't. But now we'll check if my connections would work. Okay, this doesn't fit. Can use this. Can put this there. So the way a breadboard works, we have a diagram in the GitHub, but in a nutshell, all of these are connected. So there's a metal strip connecting each horizontal row in this case, if you were to look at it like that. So you can see they're numbered. This is 45, this is 50, each one is like 46, 47, 48, 49. So all of these are connected. And right now I'm going to use that principle to check if my board's pins are deep enough into the board to make a connection by tapping. That was in the camera. Okay, so we're gonna test right now if my board's pins are deep enough into the breadboard to make a connection with these pins over here, basically from there to there. There we go. And make sure your soldering iron is off at this point or far away. You don't want to burn anything. So let's see. Cross fingers. Okay, so there is a connection, but it doesn't seem super solid. So you guys can see that the signal is cutting out. Let's test the next one. Seems better. That works. That works. Okay, this means that all of these pins on the board are going deep enough to be able to work with them through the breadboard, which is good. I can go ahead and test all the way down, connecting these pins down.